All right. In our last review lesson on fractions, I suggested that you try the questions and then go back and watch the video for parts that you weren't getting correct. This one, we're going to go back to our normal format of you probably want to follow along and make sure that you understand what I'm saying, because people often think they're doing this right and do it very, very wrong. So it seems almost over basic, but a lot of teachers don't emphasize the difference between expressions and equations. An expression is something that is a mathematical representation of something, but there's nothing to solve for. All you can do is simplify what's already there to say that this is equivalent to this. So the first few examples here I've got are expressions, and then we'll get to equations, which is where we actually have an unknown and we're trying to figure out what that unknown is equal to. So the format of actually answering them is significantly different as well, which again, people often mix up and it causes some issues. It's basically like the equivalency of horrible grammar in English is not understanding the difference between an expression and an equation. Okay, so for question 1, I'm asked to evaluate the following expressions. So 3 plus 4 squared divided by 8. You'll notice that there's no x and no equal sign in there. There's no variable to solve for. There's no equal sign to begin with. All I can do is figure out what that's actually equivalent to. So I'm going to follow my normal rules for BEDMAS and just say that I've got to do the square before the addition or the division. So that's 3 plus 16 divided by 8. And then BEDMAS also says that I do the division before addition. 16 divided by 8 is 2. And that gives us 5. So the important thing to understand with an expression is I'm not solving for anything. The left side of this equal sign isn't anything. There's nothing there. It's just saying that it's equal to the line above it. So every time I go down a line, I'm just saying I'm rewriting an equivalent expression to what's above. It looks different, but they are equal. So expressions always start a line with an equal sign. Here I do BEDMAS, and remember that BEDMAS doesn't explicitly say it, but we consider the tops and bottoms of fractions to be in parentheses. So we do the entire top, the entire bottom, and then the division. On the top, I have 6 squared plus 4. Well, that's 36 plus 4 divided by 10. The top, 36 plus 4 is 40 divided by 10, and 40 divided by 10 is 4. Again, equal sign at the beginning of each line to show that it's equal to the line above it, not that I'm solving for anything on the left side of that equal sign. Now we can have expressions that do have variables in them, but I cannot solve for those variables. So for instance, question 2a, I'm trying to simplify 3t plus 5 plus 4t plus 1. I can write an equivalent expression to that, something that means the same thing but is simpler, but I cannot solve for t. I cannot tell you what t equals to here. Now, if you're wondering how this applies to kind of the real world, if me and my buddies went to the burger place and we said, here's our order. We'd like to order 2 burgers and a fry and a Coke and 3 burgers and a Coke and 5 burgers and 2 fries and 3 burgers and 1 fry and 2 Cokes and 1 Coke. They'd look at me like I was an idiot. What it would be my job to do is put those things together to make it as simple to express as possible, to state the number of hamburgers I wanted, the number of fries I wanted, the number of Cokes I wanted. And that's essentially what we're doing here with expressions that have variables in them. We're saying how many of each thing we have so that we don't have it written all over the place. So we start off our line with an equal sign to show that it's equal or equivalent to the line above it. Now, in this case, the actual brackets don't seem to do anything, so I'm going to rewrite it without brackets. It's 3t plus 5 plus 4t plus 1. And what I can do is collect like terms. So I have 3t's and 4t's is 7t, and 5 and 1 is 6. So whatever t is, I don't know, I can't solve for it, but I know that I have 7 of those and then 6 whole numbers. And that's easier than saying 3t's, I have 3t's plus 5's plus 4t's plus 1's. Now over here, I can do the same thing. I'm not keeping track of how many x's in this case I have, but I can say something that's equivalent but different looking than this. So we call this expanding. We'll talk more about this later too. Just a reminder that when you're multiplying a bracket by something, each term in the bracket gets multiplied by the thing in front. So we have 3x times 2x, that's 6x squared. And by the way, if you're weak with this stuff, don't worry, we're gonna be coming back to this in a later part of the course. And 3x times plus 5 is plus 15x. So there's an expression that's equal to the line above it, but looks different. Now, depending on the situation, the bottom might be considered the easier way of looking at it, or the top might be considered the easier way of looking at it, whether we want it in general form or factored form. But again, that's for a later part of the course. Equations. This is where we have something that has something on the left side of an equal sign, something on the right side of an equal sign, and we are trying to figure out what the variable is if possible. So in this case, I know that 3x's is equal to 15. Now, without any real mathematical ability, I think my brain knows what x is. I'm pretty sure it's 5. But the rule for solving equations is that we have to do the same thing to both sides of the equation. If something is balanced, if you and your friend have the same amount of money, you will continue to have the same amount of money as long as I do the same thing to both your monies. So for instance, if I gave both of you $3, you'd still have the same amount of money. If I took $1 away from each of you, you'd still have the same amount of money. If I doubled your money, you'd have the same amount. And if I divided it by 3, you'd still have the same amount. So as long as you start equal and you do the same thing to both sides, your answers or each line will still be true, will still be equal to each other. What you can't do is do different things to both sides. I can't take half of one side, leave the other side the same. Obviously, if they were balanced before, they're no longer balanced. Likewise, and I see this often, I can't take 3 away from one side and add 3 to the other. Doing that imbalances things. If you have the same amount of money and I take $3 away from you and give your friend $3, you definitely don't have the same amount anymore. So same thing to both sides of the equations. Now in this case, what I'm going to do is divide both sides by 3. 3x divided by 3 is x. 15 divided by 3 is 5. That was pretty simple. So now I've solved the equation. I've said what x is equal to. It has a value. It was an unknown. Now it is a known. For this one, n minus 5 equals 9. What I can do to both sides of the equation, well, let's specifically talk about the left side. I'd like to get n by itself. So right now it is n minus 5. What I can do is add 5 to it, but then I have to add 5 to the other side. And if you have n, take away 5 and add 5, you have n. And on the other side, you have 14. I realize those are both very simple equations that you likely would have done in your head without any mathematical notation. You just would have written down the answer. But it's important to understand that when you're doing this in your head, you're really doing the same thing to both sides of the equation to make sure that they stay balanced and that you are solving and getting a value for that final answer. Okay, multi-step problems. This is where things tend to go wrong. So this is a little bit hard to explain, so I'm going to kind of just do it with the examples. But you want to think about what order BEDMAS says to do things, and we're going to always focus on our variable, the thing that we're trying to deal with. So just for a brief moment, I'm going to look at part A and say 5x plus 13 equals minus 22. Now on the left side where the variable is, I think about what happens to the x first. Do I multiply x by 5 or do I add 13? Which of those happens first? And BEDMAS says the multiplication happens before the addition. So what I have to do is basically undo the things that are happening to the x and in the opposite order. The analogy I usually use, and I'll erase this in a second, is that if I have a present, my present is this little toy doll here, and I wanted to give it to a friend. The first thing I would do is put it in a box, and then I would doll box. Then I would wrap the box in paper, and then finally I would put a bow on the box. Now, when I give that to my friend, they're going to start off with the bow on the box. And what they're going to do is take the bow off. And then they're going to take the wrapping paper off. And then they're going to take the doll out of the box. So the idea here is that not only am I doing the reverse things, I'm doing the reverse things in the reverse order. The first thing I did was put the doll in the box. The last thing they do is take it out. So I do the reverse operations in reverse order. Let's see if I can get rid of all this at once. Can I delete? Where's the delete? Come on, delete, cut. There we go. Okay. So according to BEDMAS on this question, I multiply by 5 and then add 13. So what I'm going to do is start by subtracting 13. The last thing done is the first thing I undo. 5x plus 13 minus 13 to that side, minus 13 to that side, and then I'm going to just clean this up a little bit. Negative 22 minus 13 is negative 35. And now the first thing I would have done is multiply by 5. The last thing I'm going to do is divide by 5. All right, hopefully that kind of made sense. I'm not going to go through with that kind of explanation on the remainder of these because it gets kind of more confusing as the notation kind of switches around, but the idea is still there. What I'm going to do though is show you that as long as I do the same things to both sides, it should work. So for this second one, right now I've got this 7 in the front that's interfering with the negative 2m. So I'm going to get rid of that 7 by saying 7 minus 2m minus 7 equals 6 minus 7. That leaves me with negative 2m equals negative 1. And then I'll divide that by 2, or negative 2, and that by negative 2. And that gives me a half. And you can always mentally or formally plug this back into the original equation and see if you get the same thing. 7 minus 2 halves, well, 2 halves is 1. 7 minus 1 is 6. Yeah, that works. That seems to be okay. Now this one I'm going to do using 2 different logics just to show you that it works either way. Right now, the BEDMAS says that I would do p minus 2 first because it's in a bracket and then multiply by 3. So I'm going to divide both sides by 3 first. And that means I have p minus 2 equals 6. And then what I can do is p minus 2 plus 2. Sorry, I said 2 and wrote p. Minus 2 plus 2. And I did the same thing on the other side, didn't I? Oh, my brain and my mouth are not in sync today. So that gives me p equals 8. Now, I do want to show you another way you could have done it. I could have actually expanded that bracket into 3p minus 6 equals 18. I could add 6 to both sides. And you know what? Instead of writing it, I'm just going to do it. So add 6 to this side, add 6 to this side. And then divide both sides by 3, divide that side by 3, and you'll notice that I get the exact same answer. So it doesn't really matter which one I do. Again, it should never really matter which way you do it as long as you're literally doing the same thing to both sides. What happens is when people think they're doing the same thing to both sides, but they're not doing the algebra properly on one of the sides. All right. This one here, I think what I'm going to do to both sides is add 30. Now, you may remember this one I'm going to actually do kind of a quicker way than the ones above. Part A is often referred to as a 2-step problem, and yet you'll notice that there are 3 steps or more steps than usual. Usually what you would say it is. 1-step problems tend to be two lines. 2-step problems tend to be 4 lines. And what happens is really we're doing one mathematical step and then cleaning it up. And that's because we're showing what we're doing and then doing it. So this one, I said I was going to subtract 13 from both sides, and then I subtracted 13 from both sides. What I can do is the actual number of steps is just do the same thing to both sides. So here, I'm going to add 30 to both sides. I'm not going to write in plus 30 on both sides. I'm just going to add 30 to both sides. And then I'm going to divide both sides by 60. And that gives me 2 equals r. I usually like to write the variable on the left. R equals 2. So there was a 2-step problem that was actually done in 2 steps. All right, for part D, don't like dealing with fractions in equations like this, so a good way to get rid of them is to multiply everything through by the denominator. So what I'm going to do is multiply both sides by 3. Now when I do that, I get x divided by 3 times 3 is x, but I also have to multiply the plus 2 by 3, which is plus 6, and the minus 3 by 3, which is minus 9. Now that I've done that, I want to get rid of the plus 6 on the left, so I'm going to subtract 6. And on the right side, when I subtract 6, I get minus 15. Part C, this one's going to be a little bit trickier, but not too bad. I'm going to multiply everything through by 8. Now, technically, I could multiply through by 8 and 4 and 2, but 8 does get rid of the 4 and 2 as well, because both of those have a multiple, which is 8. So when I multiply the first one through by 8, and I'll do this in one extra step than I normally would, I'm going to get 8x over 4 minus 8 over 2 equals 3 times 8 is 24 over 8. So I've multiplied the tops of all 3 of those fractions by 8. And now I can simplify a little bit. 8 divided by 4 is 2x. Minus 8 divided by 2 is 4. 24 divided by 8 is 3. And then from there, I'm going to add 4 to both sides. And then I'm going to divide both sides by 2. And I'll just leave my answer as a fraction, 7/2. That's fine. All right. Now we can get equations. And by the way, we're going to be doing lots of equations through the course, so we're going to get lots of practice as we go. But this is a skill that you cannot get through math without being able to solve equations. Basic algebra is used for everything. It's kind of like saying I'm really good at English except the reading and writing parts. You can't be good at the rest without those. So for part A, 6x minus 5 equals 4x plus 11. Again, just remember that the only rule here, other than, do algebra right, is that we have to do the same thing to both sides of the equations. Well, I have x in 2 places and I don't want it in 2 places. So what I'll do is I'll get rid of the 4x's on the right-hand side by subtracting 4x's from the left-hand side as well. So all I've done to both sides is get rid of 4x's. Now I want to get rid of that minus 5, so I'm going to add 5 to both sides. And I want to get rid of the 2, so I'm going to divide both sides by 2. That's it. This one here for part B gets really nasty if you try and do the algebra without getting rid of those brackets first. So that's what we're going to do. We're going to expand the brackets. This gives us negative 3m plus 18 equals 6m minus 2 minus 7. I'm going to just clean up that a little bit because I've got like terms, the minus 2 and the minus 7 over there. So that's minus 9. Now I got to get rid of the m's on one of the sides. I've got a couple of options. I could add 3 m's to both sides and then it would go away on the left, or I could subtract 6 m's on the right and then it would go away on the right. I think it's easier to add 3 m's to both sides. So that'll give me 18 equals 9 m's minus 9. Now I'm going to add 9 to both sides. That gives me 27 equals 9m. And then finally divide both sides by 9. And that gives me 3 equals m, or m equals 3. All right. Like I said, we're going to be doing a lot of this throughout the course, so we don't have to worry too much about um, details on any of the weirder, harder ones, but I really would like you to try some practice problems. I know there's quite a few here. If you know how to do them, these should go very quickly. So give them a shot and then double check with the answers at the bottom. If you're getting the right answers, fantastic. If you're not getting the right answers, just look over them again, see if you can figure out where your mistake is. If you can't figure out where your mistake is, contact me and let me know, and I will help you get that straightened out. All right, one more review lesson to go until we're done the review stuff. Give these questions a shot, and we'll see you in the next lesson.